second statement I would make, however, is that I personally believe that once we finally do this job, that at least scientifically, sequestration at large scale will look safe and reasonable to do. However, the carbon capture side is just way too expensive. With today's technology, I think it's optimistic to be thinking that we could get down to $60 or $70 a ton of CO2 with enough learning. Well, $70 a ton of CO2 translates to 6 cents a kilowatt hour on a supercritical plant. It's just costed out of the competition. So the real thing here is we need a technology game changer, and ARPA-E is looking at a whole bunch of approaches which are much earlier stage. We need a breakthrough that cuts the cost down by a factor to whatever, as opposed to incremental 20% changes. Lots of new ideas out there. I think it is perfectly credible that we can find a breakthrough technology here, because up to now, we haven't really even thought about it. All we've done is what we do too often in the energy space, port in a technology developed for a different reason. In this case, amine capture in the petrochemical business. So, I think I'm reasonably optimistic, but this will require a new technology. I think I'm going to skip my solar slides. I have silicon, beyond silicon, grid integration. I will mention one thing on the intermittent renewables, wind and solar, in terms of game changers. We really need to get a much better way of addressing the complex integrated system dynamics for managing intermittence with appropriate backup, appropriate firming, et cetera. We need new, transparent, dynamic simulation models. We also need regulatory innovation, at least in the sense of strengthening capacity markets in the United States, in my view, if we are going to really move out in this direction. Again, I'm going to skip this, and I'm going to skip vehicles and batteries, and just end by putting on a different hat. And this is my hat, as Richard mentioned, as a member of PCAST. Last November, PCAST did produce a report to the President on accelerating the pace of change in energy technologies, and the importance of doing so as part of an integrated federal energy policy. That last line, integrated federal energy policy, can quite justifiably lead to questions like, what is that? In some sense, what we're arguing is, why don't we try to get one for the first time? And to do so can only be done by working across the entire administration. The idea that, the Department of Energy does not have the scope or the stroke to integrate all of the energy, environmental, security, industrial policy, fiscal policy, agricultural policy that we need. So what we recommended is a process that we termed the Quadrennial Energy Review, before everything else started to be called quadrennial, but so be it. And again, the idea is, without going into detail, that, well, a couple things. One is, if we continue to do energy policy the way we've had, with frankly no analytical base to speak of in the policy construct, we may as well not bother. So, for example, we simply need to build up the kind of engineering economic analysis tools that we need to do policy in a serious way, which, if you think about it, might even be helpful to establishing something that has less of a partisan tinge eventually. To do this, it's got to be led out of the Executive Office of the President, to have the convening power, but that's not the place where you want to put the mechanism to actually be able to execute this. So the Department of Energy, we argue, should be appointed as the Executive Secretariat for this administration-wide effort, and should be the locus for the initial first steps. Because in our view, it will take 4 years to build up the apparatus to have a serious integrated quadrennial energy review. But the first step And the good news is, from our point of view, it is going on now. Secretary Chu announced a couple of months ago that DOE is now executing, and there's a draft out for public comment on the scope and the charge, what they're calling the quadrennial technology review. So it's the first step. It'll be more technology focused. Then the idea is to build from the inside out eventually to a comprehensive policy. So that's one major point, and we will be guardedly optimistic that this can be sustained. The second issue is we need more money. We need about $10 billion a year more for a serious RD&D program in the energy space. We have an argument in the report as to how you get to that number. I won't bother you with it because it's kind of infantile and silly, but the point is the following. In the end, there's no magic number from pure thought. The number really in the end comes from building up the programs. However, it's a very different charge, let's say the Department of Energy, to build up a program where you think you're talking about $15 billion rather than $5 billion. So it's really the way you condition the planning, and that will eventually lead to the number. And by the way, this is out of the American Innovation Council's report showing that as a fraction of GDP at least, we are at the bottom. And by the way, the extra $10 billion, roughly speaking, puts you up to where Japan is and the number that we think is right. There's still the question now that we've absolutely got a fantastic argument for why we need $10 billion more, we will now ask, okay, now where do you find it? And what we said is, well, look, you're not going to find it in the congressional appropriations process. Back to the future. The only place to find it, and whether we can assemble the political will, is very unclear. It's got to be on a small charge on energy. A mil per kilowatt hour, $4 billion. 2 cents a gallon liquid fuels, $4 billion. You know, you're kind of talking in the right ballpark, right? Now, it's clear this can only work if the industry and consumers, perhaps as represented by regulators, come together and say, we need this for the future, and we'll come together and support it. Otherwise, politically, it's as dead as it can be. There's no point even trying it, okay? But that's kind of the program that we laid out in terms of, I think, how we develop the policy, and the only thing that we can figure out as a credible way of paying for it on the technology side. And I'll end with this slide, which is one example of a historic success. So let's go back to our current favorite subject of unconventional gas. This is coal bed methane. And what you see here is an interesting interplay. On the left, those light blue bars are the initial, going back to 78, the initial DOE funding of some very basic work on reservoir characterization for unconventional resources. That was then picked up, if you like, the green bars, by GRI. GRI no longer exists. GRI is exactly what I'm talking about, however, in the Back to the Future sense. How was that funded? It was funded by a small charge on gas transportation. It was industry guided, and this was then the applied and demonstration work associated with developing these technologies. But very importantly, the red line was the time-limited tax incentive put in place for unconventional production. So the technology was being developed. You had the technology, but then you had an incentive which only went up to wells drilled until 1992. And that the green curve is the gas that got the tax incentive. It ended, and the blue is the still increasing, now major resource. The point is, this is exactly the kind of integrated thinking that we need from this QER to get the game-changing technologies out there, incentivized, and put in place in an economically rational way in contrast to some of our current policies. Thank you.